Nathan Cruz with Carlson Software, and in this video I'm going to show you how to use Precision 3D Topo 2017 to bring together design data in the form of design surfaces, raw survey data, and we'll do a field to finish, and how to bring in GIS type data like state provided aerial LiDAR and also imagery from the USGS national map. So the first thing I'm going to do is make sure that for this particular demo project that I'm in Kentucky North. So we provide a long list of these projections, and then you can use our add projection method to find and download new projections from spatialreference.org, which I showed in my getting started video. But in this case, we're just going to use Kentucky North. And I'm going to load a design surface that was done with Carlson Office. This could also be a Land XML surface that came from pretty much any product, an Autodesk-based product, a Bentley MicroStation-based product as well. So I'm going to go ahead and load in this design surface, and this was created using Carlson RoadNet. This design road here. It's got some ditches and some cuts and so forth. The next thing I'm going to do is bring in some survey data. And in this case, I've already picked my, from the USB demo data, there is a Maysville subdirectory, and it's got the US accident CRD. And just a quick poke around in here. Essentially what we do is we find all of the codes that were imported in the CRD, and then we have a default set of settings that we provided on the demo disk as well. So you can select from the USB demo data, Maysville, and then the field to finish settings essentially. And we've already pre-canned some of these different types of field code definitions. So here we've got a tree, and we've selected a symbol file, a 3D model, and you give it a little preview of what it's going to look like. Here, another example, we have a polyline, and in polylines, if they're closed, you can select a texture that will be placed inside of that closed polygon automatically. These are just different points. You could change a type by simply right-clicking and changing the code type from a point, polyline, or tree, which get treated differently as we do the field to finish. And let's see another example. We have a power pole. I think we have light poles in this, which are LPs. And again, so here we're going to specify that a light pole object is inserted wherever we find this particular point. And then you can also specify for all these different codes whether or not those points are going to be used for surface creation. In this case, I'm not as concerned about that, so I'm just going to click on OK. And here you can see our data that has come in with a 3D field to finish. And the first thing I'm going to do is get rid of the field to finish 10, which we create automatically. But you can see these are the building outlines, and they're contained in polygon folders with the name of the code. So it makes it pretty easy to find them. And we see our trees came in, the cars. I'd already preset up these codes for the yellow center lines as to come in as yellow and draped to the surface. And then you see our light poles that came in as well. And then of course we also have lots and lots of points. So we can also show all of the different points. So I can highlight this folder called PK, and I can say show the description so it stands out a little bit more. And there you go. Other things that you can do with the survey data when they come in, you can add the polygons. So if you have breakpoints or break lines, you can add these to a surface. You can add points or whole groups of points to a surface as well. You can create a new surface from any combination of polygons or points. So here I can create a surface just from this particular set of data. So we have a lot of different tools for importing data from raw survey data. We can do field to finish on it, and then we have additional tools once you have the data in to create surfaces and then edit your surfaces and really prepare them for your work. I'm going to turn those off for now. And now I'm going to show you how to bring in GIS data. So in this particular case, I think in our office code, they'd brought in a Google Earth surface, which they aren't actually very accurate. I mean, they're good for visualization and preliminary design, but this is an actual design road. So in a more normal work case, you basically would get this road and the daylight lines, and you wouldn't necessarily have the surface that the existing ground around it. So I'm going to show you how we can use free LiDAR data from that's provided by almost every state in the United States and load some point clouds. So really quickly, these settings, basically you can bring in the point cloud information and not provide a projection. And by projection, I mean that it's coordinate system projection where it was gathered from. You can use the projection that was, and this is the default, is if we read that there's a projection in the file, then we read that projection for each file, and we will automatically project it to the current scenarios projection. So basically, we're handling this coordinate transformation for you, but still giving you some control to override it, because you can also select it manually if you want to override it. We have a point thinning factor, so basically this just skips so this will read in every 20 points. I'll probably make that 10 just because these aren't very large. As you make those changes, you'll notice that for each point cloud, now let me select a few more of them here. We really don't need the rivers stuff. 41, 42, let's load these 4 here. So you're seeing a red preview box, and that's where the files are going to come in, and right away I can see that I didn't pick up the other point cloud on this other side. So I'm going to go back here and reselect my files. And now I can see I've definitely got my area covered. If the LiDAR data is pre-classified by software, and almost all aerial LiDAR that's provided from government agencies is classified, then you can turn on our bare ground classification filter. And if you notice, as I click on that, we're telling you the original number of points in each LAS file, and then we're telling you how many are actually going to get loaded based on your settings. So if you've got the bare ground turned on, you notice that you're going to get fewer points. If I change the point thinning factor to 0, you see it go up, and if I increase this value, you'll see it go down in value. We also tell you whether or not the file was classified, and then also the projection for each one. So we give you a lot of information about these files before you ever load them. And then we're going to queue up each load in a separate process so that they're loaded simultaneously. We do have throttling code so that if you don't have enough physical RAM to load all of these in at once, then it'll basically stage them, and it will do one at a time instead of trying to blast 8 at once. This particular machine is a hex core i7 running at 4 gigahertz, and I've got 32 gigs of RAM, so I had more than enough memory to load all of these simultaneously. So if you have less RAM, we may have to load them one at a time, and which will just take a few extra seconds essentially. Once we have our point cloud data in, what you can do is select the point cloud itself. So I'm just going to do a little window crossing here. And I think in this case, what I want to do is get rid of that one because I can see I don't need it. I'm just doing a right mouse button click, and I'm doing and dragging to the left, which is a crossing selection set. I'm going to just pick on this guy out here and delete that one as well. And what I'm going to do is select these two at a crossing. I'm going to use our merge command, and I'm going to merge those point clouds together. Because I had a straddle here for my project area, I needed to do that and then do a merge first. And then what I can do is do a crop command because I don't need all of this information out here. It's a lot of extra data. And what I can do is I can crop holding the right mouse button down and then pressing enter. Optionally, you can also import a polyline, or you can draw a polyline directly on the point cloud, and you can do a crop or delete points that way as well. So I'll show you really quickly how that works. So in this case, I'm just going to draw a polyline over here, close it, and let's see, I'll turn off my surface so you can see the effect a little bit better. I'll reselect my point cloud. I'm going to choose the delete and crop by polyline, and I'm going to use my window crossing again to select the polyline. And in this case, I'm going to tell to delete the points on the inside. Crop basically removes all the points on the outside. So I'll just do a delete points, and you see the points are gone. If you make a mistake, you can always hit Control-Z and restore your point cloud back to where it was. And again, when we have this point cloud in crop, we can then create a tin surface from it. And then we have tools to merge in that design surface right into it as well. So turn off the point cloud, and here you can see the tin that was created from the point cloud itself. And then we can merge in our road design into this, and this is a much more accurate surface model to use. The aerial LiDAR data is extremely accurate. It's also very dense, which is why we have thinning filters and so forth. So that's design data in the form of design surfaces coming from a variety of software packages, Carlson, Autodesk, Bentley MicroStation, and then also importing survey data, in this case in the form of a Carlson CRD. We could also import a land XML file that has survey data and points and alignments and so forth, and bring them in that way as well. We then used our point cloud import tool to bring in and work with aerial LiDAR data directly instead of downloading DEMs, which have a tendency to be really large, and you effectively don't have any control over all the settings that they use to create the surface. And our surface modeling and tin modeling is essentially the same as in our Carlson Civil products, which is a very typical Delaunay triangulation set of tools, which works perfectly for engineers and surveyors. The other thing that you can do is you can bring in other forms of GIS data, like shape files, and in this case I'm going to pick the demo data in Maysville off the thumb drive. In this case it's a GeoTIFF, and we automatically read the projection out of it. We support GeoTIFF, Mr. SID, JPEG 2000, and georeferenced JPEG files. That is JPEG files that have world files, which is why you can select this world file separately. And then we'll just click on OK, and we'll bring that aerial imagery in right on top of. And I'll set it pretty transparent. So here you can see the aerial imagery superimposed with the survey data, and you can see where the trees and the lines and whatnot ended up showing up. So if I turn my tin back on, you can see the rest of all that.